brief introduction to laser cutting. If you're not familiar with it, I'm talking about some of the principles, and they'll help us understand some of the decisions we're making as we go. Having a look at the knowledge base, where the existing information for this process lies, how it's going to differ a bit from what I'm going to show. And today, on that note, preparing, in this case, a non-rectilinear contour site model for laser cutting. So for some studios and some projects, the instructions on the knowledge base they're good, but they don't really cover all bases in terms of the complexity or potential complexity of a contour site model. So this session, we're just going to concentrate on keeping it relatively simple, but using that sort of non-rectilinear or non-uniform edge condition for our site models and how we can potentially navigate that. Okay, and then our FabLab file submission process as well. So some notes. No two site models are the same. This isn't sort of a plug and play set of instructions. You do need to apply these principles and exercise some design thinking as you go, specifically the fabrication and process principles, and potentially come up with some novel solutions for what you need from your model. And also to remember to design sustainably and try and find ways to use the least amount of material. This is a method of making a site model that we use because it is sustainable in the sense that it uses the least amount of material for the most sort of output, or the most impact for the type of model that we give. There is another way of doing this that we see sometimes, which is just to stack pieces on top of each other, and that results in higher costs, longer waiting time, and typically a lower quality outcome as well, in our opinion. So let's just jump into a quick introduction to laser cutting, what it is, and how we're going to apply it. So in our case, for the Fab Lab, for this type of laser cutting, it's what's known as 120 watts. So that's the amount of power. It's a laser that's directed through an optical system, which includes mirrors and a focal lens. The lens concentrates that energy into a fine high energy point or a beam, and that's used to cut or mark the materials. The optical system is integrated into an axis gantry system, and we program that using our software. So there are really two inputs: it's the amount of power of the laser and how quickly it's moving and where it's moving to and in what order. And the capability really comes down to that power of the and that relates to the speed. To get a little bit more fine-grained, the way the laser works is uses electricity to generate energy within a gas-filled tube. It sort of excites particles. They bounce around inside between some mirrors and find their way out, and that creates our laser beam. I've uploaded these slides in that folder I shared, so if you want to read the more detailed component, go for it, but I'll just fly through them now. So what can we do in the Fab Lab with our laser cutters? Well, we've got what kind of laser cutters do we have, I should say, and what can we use them for? Like I said, we've got the 120 watt ones. These are the typical laser cutters that we're making a contour site model from. Good for plywoods, thin acrylics, MDF, boxboard, paper, card, polypropylene, things like that. And then we've got a more powerful 400 watt Kern laser cutter. So if you're interested in laser cutting things like steel or stainless steel or much thicker materials, that's also possible. For our bureau stock, I'll show you where you can view the material list and prices. These are our primary laser cutting materials. So we've just changed our plywoods to laser ply, including radiata, which is a pine, and a blackwood. So they're much more premium materials than we had before, which is really nice. Make some really beautiful models. Some of the typical materials that we've always had are MDF, got our polypropylene acrylic, so Perspex, as it's also known as. Boxboard is a popular one for contour site models. It's cost effective and quite robust. Screenboard, similarly, we see quite a lot of site models, contour site models in the screen board. So that's a white cardstock, Splendor gel, and optics card, which are much thinner materials. And there's plenty of other materials out there. We do allow our own materials. So if you want something different, something that we don't offer, you can go ahead and bring that in. There are some uncuttable materials, however. So certain materials, PVC is the most notable, we can't cut through. And there's more information about that on the knowledge base if you're thinking about cutting something non-standard. So what's the basic workflow? We make our model, as we're going to fiddle around with today. We're going to work on our model. We're extracting curves. All of this happening in Rhino in our example. You can use other software to generate geometry and then bring it into Rhino for submission, but today we're just using Rhino. We're nesting that geometry onto a template. We're posting it, which is a process that happens in the makerspaces in Fab Lab by the technicians, and then the cutting takes place. There's plenty of different methods around designing and fabricating with laser cutting. So perforated folding is a really good one where we turn our lines into a hatched line or an etched line that is broken, like a hidden line type line. And that means that we can take out most of the material along a curve and not all of it, which gives us a really nice clean fold. Contouring, which is what we're going to talk about today, basically just stacking up cut sheets or planar pieces in order to create an approximation, an abstraction, or an interpolation of more complex surfaces in an efficient way. Plotting things together, so waffle grids and torsion box structures can be really interesting ways to apply laser cutting. Tabs and hooks, you can get into the design of how your laser cut components come together and how that can influence your design, your model, and your methods. Finger joints, we'll do some finger joints today. This is a really, really simple way of just bringing parts together and aligning them quickly. Typically, you also need to include glue in these joints as well in order to get them to hold. And then just a note on after cutting. So certain materials like plywood and MDF, they contain resins. So you'll see sometimes in this example image as well, you get a bit of afterburn on the surface, and there are a few methods. We've got them detailed on the knowledge base and here as well for how we clean up things afterwards in order to get rid of those extra marks that can make your model look a little bit more, I guess, dirty, really, is what it is, and a little bit less refined. So some common mistakes with laser cutting are too many small details. So the software struggles to process huge amounts of information. That often happens with architectural models with lots of etching of things like brick hatches and stuff, things like that. Overlapping curves, lines during processing. So where geometry exists sort of duplicate in the software. The process means that sometimes it will cut in a certain line or a certain place twice, which can ruin your work. An unnecessary amount of complexity sort of goes back to that point about hatches and such, and component size. So small parts can drop through the bed. There's a grid bed that holds our material up, which is 15 millimeters by 15 millimeters. So any small parts require little breaks in their lines in order to facilitate them being cut and not being lost in the machine. So importantly, knowledge base. Okay. So I usually just say to people, just hit up Google, MSC Fab Lab, best way to go. You land on our website, we've got lead times, we've got places to book consultation. Like I said before, our materials price list can be seen here, so you can jump straight into materials that are part of our laser cutting bureau service. You can see their costs in a little preview. So Blackwood and our radiata, for example, I spoke about just before. If you haven't done them yet, the makerspaces inductions, they're not necessary for submitting to the bureau or doing any laser cutting, that's fine. And our Fab Lab knowledge base. So this is where we're going to find information on laser cutting, our primary information on setting up these contour models. So we've got our laser cutting guide with an overview, a little bit more detail than what I've just said, some of the specifics, the technical specifics, and we've got our quick start guide in here, some video tutorials which cover file setup in a lot of detail should you need it. And then importantly, we've got creating a contour model right here. So this set of instructions that you may or may not have already seen will take you through the steps that we're going to take today in terms of creating a contour site model. This, as I said, is a very rectilinear example, which makes it quite simple. And what we're going to try and attempt next is to show you how to do or indicate a way of doing something that's a little bit less standard. And in so doing, go through the same steps with some slight adjustments. As I mentioned, there is some more information about other ways of using laser cutting for advanced techniques, and also that same information about post-processing, so cleaning up, sanding, cleaning up the parts afterwards as well there. So, as I said, in the chat, I put in the link, which has our folder with some assets in it. That includes a Rhino file used today, being this file here. And this is our starting geometry. So what you can see here in Rhino speak is a trimmed surface, or a cut surface, so to speak. So every surface in Rhino in its pure form has 4 edges. So when we have a surface like this one, where it's got many more than 4 edges, it's actually just sort of a mask of a different surface. So it's kind of like a trimmed version of the surface that's underlying it. This tutorial isn't going to go into how we come to this surface. In my case, I use a software called CAD Mapper. Should you want to extract some data for yourselves, you can use CAD Mapper to create mesh surfaces. The catch with that is that, yes, you bring in a lot of information about things, but you will also be bringing in a mesh surface, not a native nerve surface, which is what we're dealing with now. So if I'm just going to quickly change this back to a mesh for us, and just to show you the process. So this is sort of a surface that is actually a mesh. It's a different type of geometry to what we're going to be working with. And if you were to use, say, CAD Mapper, this is what the type of surface that you would get. We can simply say mesh to nerve in Rhino and get a poly surface back. You can see it's rebuilt it quite poorly because I've been going through too many cycles of rebuilding it. But when you do get a mesh in from something like CAD Mapper and you do a rebuild mesh, it will rebuild, mesh to nerves, it will rebuild it much more cleanly. So, like I said, we're not going to dwell on how we got to this form. We're just going to jump into how we turn this into our site model, following those contouring steps. So, layering is going to be really important for us in this. Keeping control of our geometry through the use of layers is really, really helpful. And often what I want to do is just create a duplicate that holds my original geometry in it. So what I'll do is I'll put this into the sub layer like so, and then I'm going to duplicate layer objects. And I'm just going to create a copy of that input geometry. Okay, that's very helpful in case I mistake down the line. Currently, this geometry is at 1:1. So the first thing to do is try and get an assessment of what I want my model to be and at what scale, and how that's going to fit in with the Fab Lab processes, especially around laser cutting. If we jump back to our laser cutting guide, and also if you pay attention to the materials, but you'll notice that the cutting area that we use is 900 by 600 millimeters, okay? We can do larger things on the one larger laser cutter that we have, but the largest stock material that we run is that 900 by 600 dimension. And it's worth checking back in that materials list on the website what it is that you want to use and what are the limitations on the X and Y plane, so 900 by 600. For today's example, I'm going to suppose that we're using boxboard, and we're using boxboard in two thicknesses, the first being 1.8 millimeters for our top contour surface, and the second being 3 millimeters for our sort of sides and structure. I'm also going to use some black optics card as sort of a finishing strip on the side to kind of clean up the model. That's optional, but because of the non-rectilinear nature of our edges, it makes some of our joints a little bit ugly. And having sort of like a finishing panel or a finishing strip of something simple like paper could also be maybe thinner boxboard if you prefer, or a different material. It will really help us sort of just clean the model up a little bit. So taking that into account, boxboard in the Fab Lab comes as 600 by 900 sheets. So those are my limits, really. Unless I want to go much bigger, it can really complicate the process of creating these contour models by splitting them onto multiple sheets. The efficiency really comes from keeping it within the sheet, but it's not impossible by any means to do that. The first thing we're going to do is we're going to scale. So I'm going to select my geometry, use scale command. I'm just going to select any point here. And I happen to know that for me, the scale that I need for this is 1 to 500 to make the model that I want and to make it fit. But it's a case of really testing some scales. So 1 to 500, we're going to rescale. With the geometry still selected, ZS, going to give me zoom selected. And I'm going to just quickly rotate with the rotate command and bring this so just to align it to my axis, a little bit easier. And we're going to use the distance command. I'm just going to get a sense of the dimensions. So 781 millimeters is what I'm seeing on my longest dimension. And over here, on my widest dimension, 419. So that fits within our laser cutting size. From a model design point of view, I'm going to suppose that for me, 1 to 500 is great, and it shows what I want to show. If that's not the case, if you do need, say, 1 to 250, and you need to break out across 2 sheets, that's okay. It's sort of a step further down the line. Don't let it deter you. It's not incredibly inefficient. It's just not quite as efficient. Okay, so there's some important geometry here, which is our surface and our outline. The surface is what we're going to cut into different layers in order to laser cut and stack. And our outline is going to help us determine our base structure, our base plane, and our vertical sides as well. And also define structural components within the model. This is quite a large span, 730, whatever it was. It's quite a distance across here. So with boxboard, we're going to need to add some support in there just so that it doesn't sag. If you were concerned about that, using a stiffer material like plywood, although it might be a bit more expensive, but you'd get away with less internal structure because it's not cardboard, it's a stiffer plywood material. It's a great way to make the timber look model without spending lots of money on solid timber and CNC machines and all kinds of process. So first thing I want to do is I want to create a bounding box. We're going to just use a new layer and we're going to call it our working model. You can name a layer anything you like. I'm going to call this working model and I'm going to put a bounding box. Oops, bounding box layer. And the first thing that I want to do is I just want to create a bounding box around that surface. So I select the surface and I use bounding box. Now, we can't really see it so well. I'm going to move to ghosted mode here. That's very helpful. I can see what I'm doing a bit better. And the next step is to basically slice through or contour this surface. If you were looking to make a more complex intervention on your surface, that can really complicate this kind of stage. That's not something that we're going to cover today. I'm going to cover that in the next iteration of this session because we just don't have enough time. But for the time being, we'll just proceed with the idea that you're just wanting to articulate a simple surface and maybe you're going to drop some objects or some buildings. So selecting my surface, I'm going to use the contour command, surprisingly. I'm going to select the base point of my bounding box on any corner and then the top point like that. Now, up in the command line, it's asking for the distance. You can see it already says 1.8 here. As I mentioned before, I'm going to use 1.8 mil box board to create my contours on the top surface. So if it did a different number there, for example, I could just type that in and press enter if I wanted to say 2 millimeters or 3 millimeters if I was using a different material. I'm using 1.8, enter. And then you can see what we get is those contours emerging through the surface on that axis that we defined with the bounding box. Okay, great. So we don't need our bounding box for a second. Not even on the bounding box, so make sure what we're saying is right there. There we go. We don't need that for a second, and we also don't need our input surface. So what we've got now is our outline and our curves. I'm going to go ahead and just select all of that, and I want to just Alt drag it across. If you've got Gumball on, if you don't, Gumball C-plane is down here, and you can turn that on and off. It gives you this Gumball. Holding Alt and dragging will give you a duplicate. Alternatively, you can use copy command. Now I'm going to select all of this, and I'm going to use the project to C-plane. Asking me in the command line, do I want to delete the input object? I'd like to, yes. So now we've moved all of our geometry down onto our C-plane, our construction plane. These curves here at the moment exist on our default layer. What I'm going to do is I'm going to create another sub-layer in my working model. Right. Contours, right. Original contours. And I'm going to move them to that layer there. Sometimes changing the color can just stop going. And in our working model, I'm going to lay the cutting line. So within that, I'm going to make a cut and also another sub-layer called etch. At this stage, I'm going to change the etch layer to red. Visualize better. Don't need my contours visible anymore. And I want to move this copied bounding edge, move that on the layer as well. So in that instance, I also don't need that outline. Okay, so we've got this set of curves. They're currently all on a varies, which means they vary in layer. I'm just going to move them to the cut layer. They're all lived together on the cut layer now. And I'm going to duplicate them again. In my case, I'm using the Gumball, drag Alt, or Alt drag, I should say, and I'm going to create 2 copies. Now everything is currently on that cut layer, and I need to move some of the information across to the etch layer. In order to create this step logic of the model, we've split it out into 2 halves, and we break each half into alternating components and then realign. So what I want to do, and I can do this in my top view, you can either click up here or you can just write the word top and line to get to top view. What I want to do is identify my lowest point. So in this case, this model, my lowest point topographically, that is, in the site, is down here. And I'm going to start just selecting alternate curves. So, and I want to move those alternate curves now onto that etch layer. So, and then in this set, we're doing the opposite. So I'm going to do this one and then go. Tiny little one. Might not be necessary. You can sort of cut off those really, really tiny bits. Sometimes they're more trouble than they're worth, but we'll give it a go today. Okay, so now I've got those set on their alternating sets or alternating layers. I'm going to go back to this just reference. And we can see those laser cut lines on the cut there. I'm going to duplicate these out again. I'm going to grab them and Alt drag. I'm going to create a new sublayer. Now we're model. I'm going to call it split. So within that, again, create new sublayers. Cut. Etch. Again. Now, the reason for that is I want to isolate some of this geometry onto save it for laser cutting later, but I also want to use some of it for generating our model. So what I'm doing is I'm just going to lock off my etch layer. I'm going to select these curves. I'm going to move them to surface split cut. So they're on a different layer now. I'm then going to change alternate to the cut, and I'm going to move the, oops, sorry. I want to lock that layer as well, that cut layer. I want to just select those etch lines, and I want surface etch. So, and then I'm going to go ahead and turn off this laser cut line. So right now we're working in this set. Again, how you choose to organize your layers is totally up to you. I probably do it differently every single time, but having some kind of logic that you can follow is really essential to keeping control of what's going on. Okay, so the next step is to split out our components and start to stack our contours. In order to do that, I'm going to select these outside curves, those two, and I'm going to use the planar SRF function. I'm going to turn the inside or use the bounds of that curve to create a surface. There. Okay. Under my surface split layer, I'm going to create a new sublayer. I'm just going to call it surfaces. So might just change the color. It's different. Make sure that those are on their own layer. So we've got good control of them. Not sure. Sometimes the color you choose makes a big difference how legible your model is while you're working on it. Okay, so now we've got these surfaces. We've got our alternating lines. What I need to do is I need to split these surfaces by cut lines. So I'm going to select them, and then I'm going to use the split command. Hit enter. We're going to select our cutting objects. So in order to select our cutting objects, we want the surface split group here, and we want the cut lines. And I'll right click and go select objects. I'm working in Rhino 8. Select objects is up the top here. In Rhino 7, it's somewhere further down. Okay. I'm going to select those objects. You can see they're highlighted, and I'm going to hit enter. What I get is those surfaces split down via those cutting lines. Great. So now we've got those surfaces split. I'm going to create a layer again in my working model layer, and I'm going to call it extruded surfaces. Okay. I'm going to use the command now called SEL SRF. So select surface. And that's going to select any surfaces within my Rhino world. Now, because I've only got this one thing going on, all I'm doing right now is selecting the surfaces that I want. Everything else is hidden. If you've got a complex model with lots of things going on, you're probably going to be selecting surfaces all over the place. So just bear that in mind, that you're selecting the right thing at the right time. Now I want to create my thickness. So we're going to use extrude SRF, so extrude surface with that selected. And you can see I can now pull out thickness. There are some options in our command line here which are really important to pay attention to. So Solid, yes, we want that. Delete input, yes, that works for us. We're going to delete the surfaces. We don't need them after this stage. You can see the extrusion distance is already preset here as 3. If I was to type a different number in, which is what I'm going to do, then I would get a different result. Now, because I actually want to pull my surfaces down, what I need to do is I need to put in a negative number, so negative 1.8, because I'm using 1.8 in the box board for my top. Once I put that in, I can hit enter. And you can see that we've deleted those individual surfaces. We've got these extruded geometries now. These are poly surfaces, so they are blocks. We still have all our other geometry. It actually hasn't gone into the negative space, which is a little bit annoying. So I'm going to use cell polysurf. So select the poly surfaces, and I'm just going to use my gumball quickly. Click on that arrow and say negative 1.8. Great. I can see that my etch curves are right on the top surface. So the next stage is a little bit tedious, or a lot tedious, and it's stacking the model. We need to do this in order to ensure that we can build the substructure and the edges correctly. So I'm just going to go ahead and get started. As I go, I like to group these objects together, and I typically will find a corner like so. I'll use M or move, and if I put in 0, it will take it to this world 0 position, and that's where I'll do my building. So we're starting with this piece here, and then we're moving on to this piece. Oops, this piece here, for example. This piece, this component is actually redundant. We don't need it anymore. And what I would do is I'm selecting this front edge, and I'm aligning it to that edge. We can see how it. So when you get to laser cutting your model, you will be able to do exactly the same thing when you're assembling after it's been cut. You'll have those etch lines as a guide for you to then assemble your model, and that's really helpful in creating an accurate model. Okay, you are just going to have to watch me do this. Now, this isn't what we're building now. Isn't actually in terms of the contours what we're going to cut. We've already created those curves. We don't need to build this to create those. This is purely so that we can create the base structure and the edges. So, you know, we're more than halfway there really on part of actually creating contours. We'll go back after this stage when we're laying things out, and we'll add some other information. So if you've got things like road outlines or other parts of topography, perhaps a scale bar, perhaps a label, something like that you want to add using etching, we can, of course, do that as well. Part. Sorry, if you're getting vertigo. Sometimes when you have these really, really thin little geometries, they do get a little lost, but it won't really. And when I say lost, I'm during turned away a little bit laser cutting. Now you can imagine if you have a large model, but for all the time that you need to spend in drawing the geometries, you will save a huge amount of time on processing. So the time is cut, and well, you won't really necessarily save much time on assembly, but the assembly will be straightforward for those curves. Sorry, those X lines starting to go. All right, cool, we've done it. Okay, so you can see we've got where our original cut lines were, and now we've got this surface that's been established in space. And if we bring back the geometry, see the thing slightly here, but you can see how those planes are interpreting or abstracting that surface into something that we can place. Not always perfect. There seems to be a little bit of shift here, but for the purposes of architectural representation, usually quite good. Okay, might have been that I made a mistake, but yeah. Let's go back and check this. Fully here. Yeah, so I made a mistake. Funny. Properly. Yeah. Okay, so we've got those. We don't really need this geometry anymore. But we won't throw it away. What I need this. We do have our outline in multiple places. Well, should align perfectly. In fact, let's turn off. I've got this outline, and that's the outline. Now, this is where we set up the depth of the base of our model. So we don't want the model to end on this lower contour. We want to add a bit of depth to it, give it a bit of visual weight, and also a bit of structure that's really going to help it out. In order to do that, all I need to do is with my curve, my outline curve I'm on, I'm just going to drop it down. So in my case, we use the gumball. You can also use the move command. I'm going to say 20 millimeters. That's the type of this number for this model. I don't want to make it ridiculously thick because I'm just using more material. But 20 mil is good for, it's not too fiddly. It's got some substance to it, or some structure. Okay, so back in our working model layers, what I'm going to do is I'm just going to double check where these are aligned. This one varies because we've got both etch lines and these extrusions. That's okay. In our extruded surface layer. What I want to do is just create another working model sublayer. And I'm going to call it face. Inside that, I want to do my outline curve, that's sort of a reference curve. And we'll take this outline that's currently sitting on that other layer. And I'm going to just move it to that. Oops. Please. And I might change the color again. Curve. So we can use that multiple times as a reference. And so now that we've got this outline curve, we can extrude it up. But because, and this will make a little bit more sense as we go, because we're not joining rectilinear forms, so we're not joining things at right angles in a lot of our corners, it can make those joints a little bit unsightly with the methods that we're using. So like I said before, one of the solutions to that is to use a finishing strip of something thin like paper just to cover that over if we choose to. In order to sort of prepare for that, I actually wanted to use an offset function, and I want to offset roughly by the thickness of what that finishing strip is going to be. So select the curve and we use offset in our command line. And then you can see if we zoom in that we can pull a new curve either side of that. We've got a distance to define. I'm going to use a material in the Fab Lab, the Fab Lab Bureau menu, so to speak, called Optics Card, which is black. It's black card. So I'm going to use that for. I'm going to hopefully I'm not still on mute. Sorry, I just saw that message. Just let me know if I'm still on mute. But I'm going to use that optics card, and I'm just going to offset the curve by 0.5. Okay, maybe you can't hear me. Just talking to myself the whole time. Good. Huh. Doesn't look like I'm on mute, but from my end, see the microphone going. Going. So I've offset that curve by 0.5 millimeters in this case, which is a little bit more than the material, but it's good to have a little bit of a margin there, more or less that. Most card stock is 300 GSM is maybe higher. What I'll do next is I will then extrude this curve. So extrude DRV is that command. And you can see again, we've got this push-pull happening, and we can fiddle around with our settings. So we don't want on both sides. We don't want it to be solid in our case. And in terms of the distance, all we really need it to do is basically slice up and through our surface like that. I can see that there is still a bit of a misalignment in my curves down there, or in my contours. So I'm just going to go back and check on that. What is going on? So yes, there's quite a bit of misalignment. We're lifting off into space here. That. Look, yeah, this is what you really do want to undo you. Okay, let's block that out. Okay. See, oops, no, there's more. Sometimes the risk with the ghost is collect through something. Has its benefits, but it's got a nice clean line happening. Cool. Yeah, that's looking. So you can see it's cutting at an offset there through those surfaces. And we can then use those surfaces to split this surface. Sorry, we can use these poly surfaces, our contours, to split this outer surface and define the boundary of our base. So that outline curve is now sitting, that outline curve is now sitting down here. We're going to change this to new layer, sub-layer, we'll call it, outline surface. So we're keeping on top of our geometry, change the color, and I'm going to move it to surface. Nice and hot. We're then going to use our split command. So in the command line, after I select that surface, split, and I'm going to select my rooted surfaces split. Okay, our extrusion is sitting on the wrong layer, so there they are. That's okay. We did kind of want those to working model surfaces split. Working model. Oh, on this layer. Okay, let's just correct that. Let's put those now. Layer. Sorry. So we're going to split this outside surface again, and we're going to use our extruded surfaces to do that. So enter. Okay, and now what we can see is we've got two poly surfaces here. We've got the one above and the one below, which is what we want. Great. I'm going to delete the one above. There's also often going to be, no, in this case there isn't, which is great. Sometimes there are surfaces that are sort of sitting right on the edge of this. Oh no, there we go. There they are, hiding. So it's kind of split those surfaces out and made lots of small surfaces as well. We can use cell SRF, like you can see here, and we've selected those surfaces again. And the reason cell SRF worked in that case is because this is a poly surface. Those were individual surfaces. See this one still hiding in here. It's a poly surface. There's a few poly surfaces. If instead I did cell poly surf to get everything, I'm going to go ahead and deselect. So I can deselect by holding Control and clicking on something. So deselecting that, now you can see it's also selected all of my good surfaces I want. So what do we do about that? We're going to go this layer live, we're going to lock hide this, perfect. And I'm going to try that again. Cell poly surf. Select and delete those little surface fragments that I don't like. Cool. Turn that layer back on. See how it's coming together. So we've got now this poly surface that slices into our contours, as you can see here. Great. So we're starting to build our boundary. Now, I want to, this outline surface, I want to make sure that I preserve it because I'm going to use it again for that finishing strip. So what I might do is I might just duplicate the layer, object, outline surface, and we'll call it finishing strip. And just to make sure that I don't accidentally damage the geometry and have to rebuild it. The next stage is a little bit more tricky. So the next thing I want to do is I'm going to explode all of these surfaces. So I'm going to select the poly surface and I'm going to type explode. And what I get is the individual planes for each edge. So, and I can then go ahead and start treating them like material, so giving them thickness. And again, we're going to use our extrude SRF. So extrude SRF. We can do this push-pull. Okay. I'm going to pull inwards. Now, like I said, very early on, I'm going to use 3 millimeters of boxboard for our, or 3 millimeter thickness boxboard for our edge condition. You can use something else, but I recommend using something stronger than top surface, the 1.8. And our inputs up here, we do want solids, yes. And I'm happy to delete the input because I've duplicated that outside surface for later if I need it. So I'm going to go ahead and delete that input. So I'm just going to hit 3 for that thickness and enter. And I need to do that for everything. Now it's already preserved 3 in memory, so all I have to do is click and heat function, drag it out and hit enter, and it will give me that 3 millimeter extrude. Enter. So just making sure that we don't miss anything. That E, yes. Okay, so we see we've got some thickness to this edge now. It is extruding into our curves here. You can see how it kind of creates a little step, a little bit for everything to sit on. Great. Cool. We're getting there. So, silly enough of me, I've just, no, I've done an outline surface. And we'll just change that. Yep. So we're going to outline poly. It's no longer surface, it's now poly surface. At all. employee service. The final component that we want to do, and we can use this reference curve that's still sitting here, so our outline curve, is we want to make a base piece as well. Now the base piece can sit sort of up inside, or it can sit on the bottom. It really doesn't matter. It's up to you. We're going to put a finishing strip on. So what I'm going to do is I'm going to make it on the bottom. It's just a little bit easier to model. I'm going to say extrude CRB. That's going to give me a incorrect one. I wanted this offset version. Not that offset one. One that's a little bit smaller. Right. Extrude CRB, perfect. And again, it's just 3 millimeters, just like before. Oops. So I didn't have my input selection correct there. It was set to not solid, so we do want to change that to solid. Okay, so now we have a base component as well. So the next thing that we need to think about is how do these pieces join together and how do they join to the base? In order to just see things a little bit better, I'm going to turn off a few things. There's this one here. That should just turn off is just visual clutter for us at the moment so that we can see our primary geometries. Pink is a great color, but it's probably not the color that I want for this modeling stage. Going on. So as you can see, importantly, how these things intersect, because if we extruded them off the face, this is where the complexity of these non-standard edges comes from. Nothing in here, by the looks of it, is actually a right angle. And that's okay. It doesn't mean that the model are made. It just means that, like I said, those joints aren't necessarily going to be the prettiest, and we have to accept maybe a little bit more of a loose way of joining things together, and then use something like a cover strip and some other components to ensure that it's structurally viable and aesthetically what we want to do as well. So if we want to start off somewhere easy, I mean, this is the easiest place to start thinking about how do these two parts join together after they're cut. I'm going to use, and we're still on this outline polysurface layer, I'm going to use a box command. And in the box command, I have the option of doing a 3-point box. And what that allows me to do is just build these sort of boxes off axis, like so. Direction, and I can build a box which we're going to start to use as a finger joint. So what I typically would do with any edge is I'll start at the top, I'll pull it down to the middle, and I'll create that box, which is an extrusion. And then I'll use M for move, and then V, enter, for vertical. And I'll just select the top and bring it to the middle, like that. So what that does is gives me a box in the middle of the edge relative to the edge length. So this box, as you can see, is aligned to this panel. I'm going to move it out so that it's like a positive in the finger joint situation. It's a little bit out of line. Better. So I can then join these two, and to join them, I'm going to use Boolean union, B-O-O-L-E-N. And that's going to join them together. In Rhino 8, it'll automatically do something called merge all coplanar faces. So it'll merge the faces of those geometries. If you're in Rhino 7, you'd use the merge all coplanar faces command after the fact, and that will matter for extracting curves for laser cutting in a minute. Now, in order to facilitate this joint, we need to create a negative space in this corner. So we go ahead and take another box. 3-point box again, 3, and realistically, I just need this one to go size right. I just need this one to allow for that one to fit inside of it. M and B is going to give me move vertical. Right, so, and then I can say, instead of Boolean union, I'm going to use Boolean difference. difference. So, and that's going to give me the geometry that is the inverse there. Okay, so we can see now that we've got a positive and a negative joint. Okay. For the sake of time, I'm not going to do that for every single corner. I'm going to do one more complex example, and I'm also going to do a lower edge example. But you should expand that process around to every single corner for your model, absolutely. What's another good? I mean, this is the most complex corner by far, and I think the best way to approach it is to think about, again, how small this material is, and there's lots of ways to join it, but think about the fact that we're going to add another finishing strip on the outside, and that should add some structural integrity as well. But in order to make it more assemblable, we're just going to cut one of these surfaces back to its minimum dimension. In order to do that, just rotate this around a little bit better. We're going to use the plane command, P-L-A-N-E. Hit enter, and I'm going to use V, enter for vertical again. Just select 2 points. In this case, it's these points. And I'm just going to create a vertical plane like so. This plane, at the moment, you can see how it's intersecting here. It's not quite what we want. We want it to just touch where the two planes come together. And we're going to use this plane as a cutting instrument. So it can be a little bit larger. That's fine. I'm just going to use scale 1D to show how it extends outside. And what we'll do is I'll just take this plane, which is being intersected, sorry, this polysurface side, which is being intersected by the plane, and I'm going to use Boolean split. I'm then going to select the plane as our cutting object, and what will happen is it will split that off into two components. Select the one that I want. There we go. Okay. So now we can see that this one's terminating short. Now, the reason that everything that I'm cutting off is ending in this this sort of butt joint, this hard edge, and not sort of like an angle or anything, is because that's within the parameters of laser cutting. The laser cutter can't cut angles into those edges; it can only cut straight edges from the top face downwards. Okay, it can't see underneath things, and it can't cut downwards. So it kind of looks like that's a disjoint edge, but when you think about how thin these materials are, some glue in that edge is going to make it reasonably strong. If we wanted to clean this up a little bit more, I'd be adding another plane in here, again using the vertical function. Oops, not like that. Again, plane B. Cool. I'm just going to cut this off where it overhangs on that base piece. So bring that up. Use this cutting instrument. A Boolean split. This object. Then we've got a corner that's a little bit more manageable for us going forward. So you need to apply this kind of logic to every single corner for this type of model. It does seem counterintuitive. You sort of think, well, okay, but isn't that going to weaken it out? I'll show you a method that we can use to make it stronger. And we also need to remember that we do have this base piece, and that's going to do a lot of work for us in terms of joining everything together. So on that note, let's have a look at what we would do to create an intersection between our base piece and our side pieces. I'm going to use the box command again, and I'm going to use that 3-point subcommand, and that's going to allow me to create 3 points to create a box. I'll drag that downwards into our base plane here. I'm going to move that. It doesn't really matter where you move it to. You can just input an arbitrary figure. So I just put in 50 millimeters, like so. And then you might say, okay, well, that's one. I'm going to do another one. I'm going to do 2 per piece, and I'm going to do the same in by 50 millimeters in that direction. Okay, so we've got 2 of these little notch friends here. We're going to go ahead and use our Boolean union, and you can see that's turned that into one piece, which is now intersecting with the base. And then I'm going to use my Boolean difference and select this as our cutting object. Right now, it does duplicate things. So sometimes I'm doing different, so I'm just going to delete the input geometry there. And you can see we've got two geometries. We've got our base plane with those notches cut out, and we've got our side plane with those positive notches. So that is what you would again need to do all the way around for each edge in order to make that connection. Another thing that we can do to reinforce these corners where the corners themselves don't come together well is to create a slicing component, or like a wedge, so to speak. So the way I'm going to do that is I'm going to just get into the corner here where these two converge, and I'm going to draw it out quite simply. It doesn't really matter too much at this stage what it looks like. It's just going to be this wedge object like so. And we might say we're going to use our M command and B. I should say I used a polyline command to draw that, which allowed me to snap to a few points and create that triangle. You can draw something a bit better than this. And I'm going to move it to the middle plane there. Great. You could also offset a bit further up high, which might make it stronger, so it's countering the bottom plane connection and working a bit higher up here. I'm then going to use extrude PRV, and I'm going to give it some thickness. We're using 3mm box board for our structure, so that's the thickness I want to give it. And now we've got this corner component. You could leave it like that and just eyeball it, glue it in if you wanted to. But I think the smart thing to do is to say, we're going to use our box command again. You can see that this one is on plane because I rotated to start, so I don't need to use the 3-point in this case. I can just find edge as a reference like so, and find another edge as a reference. So now I can do this, and Boolean union that, and then we've got another tab sitting on our plane here. And then if we were to do that on the other side, make that box command. I'm going to use 3-point this time again. I want to use 1, 2, 3. So doesn't really matter again where I put it this time. Boolean union. Okay, so now I've got this wedge and it has tabs, and those tabs are going to allow me to index the edges. So what I can go ahead and do is select this side again as an example and say Boolean difference. Select this as my cutting object. And now this has a negative side where that will flip right into. Do the same over here. Okay, so now this part not only works to help the structure hold together, but it's also helping us to index things in their correct position. You can see again with that Boolean difference, we've got 2 inputs. I just want to get rid of the input geometry. It might just be that when I did the command, I didn't have my settings quite right, so just check that for yourself. And we've got, yeah, those 2 geometries. So including like wedges or supported wedges like that into each corner, and they can take up, they can be large, they can span large sections or whatever you feel is required. It's going to really help you bring the model together and give it some proper structure. I spoke before about the spanning, so the distances that we want to cover. A nice way to deal with that might be something similar. So it might be that I want to do something that allows me to easily, even though these faces are not parallel, run a support through here. That support can then hold up the contours in the middle so that they don't sag working on it, or when you've got your model sitting on it or whatnot. So in order to do that, what I'm going to do, once again, I'm going to use that box command. I'm going to select a point over here arbitrarily. There's no science here. It's just sort of finding the middle of the space where you think a support might work and dragging out a new box. I'm just going to drag this out randomly, and I'm going to resize it so it can get way too big. Okay. I'm just going to use scale 1D, and I'm going to resize this to its 3mm dimension. I'm also going to resize it so that it's a bit bigger than the edges there. That's fine, because what I want to do is I want to cut it with our contours. And I'm going to do it twice. I'm actually going to do one in this axis and another one on this axis. So I just copy that in place. Go this down, go 1D. It may not be necessary to do this cross section, but for demonstration purposes. So the first thing I want to do now is turn those extruded cells on. And then just one at a time, I'm going to Boolean difference. I don't want to overload the Boolean difference. I especially don't want to put these two intersecting planes on it because it can confuse the algorithm and you can end up getting a suboptimal outcome. So oops, select those layers with my cutting objects. Sorry, those contours. And now you can see that I've got above, they've got the original geometry, change the setting, I've got my above. So I'm able to then go ahead and get rid of that. If we look underneath, we can see that that support now runs along those contours and supports it in the correct position, just like the edges do. And that's exactly what we want. So we can go ahead and do that. This one. Again, select those objects, cut. We can delete the original geometry and we'll delete that upper section. And that piece does the same. Something to be wary of here is how those angles appear because of the way that we're cutting. So what we want to do is select the face with the least amount of surface area in this case. So what I do here is the dupe face border. Dupe face border will allow us to select the face of something and duplicate its edge. So you can see like that. And we hit enter. I'm then going to delete that input geometry. Got this curve here. I'm going to use extrude CRV. I'm just going to put in my 3mm number again. And then you can see that that sort of deep cut doesn't exist anymore. And that's more true to what the laser cutter is going to produce for us. In fact, it's very true to that. And you could do the same on this object here as well. You can also go ahead and add things like these lower tabs onto these objects and then intersect that with our base piece so that you might have tabs that fit into that base as well. For say this intersection, this one's quite simple. I can just go ahead and create a box. So like I did before, bring it up. M for move, V for vertical. I'm going to bring this up to the center. I'm going to say union, and then I can say Boolean difference, lead input. Yes. Oops. No, that's not quite. Boolean union, lead input, delete cutter. What do we want to do? We want to delete the input. Yes, we don't want to delete the cutter. Great. Much better. Okay, so now we've got this geometry with a slot ready to take this piece here as a structural support. Importantly, we also have this intersection to deal with. So obviously these pieces don't just fly through each other, and the logic is very much the same. It's going to be our box command, arbitrary, I suppose. It doesn't matter too much. As long as what we do next is to copy this, and we're going to hit B vertical, grab a corner, drag it up, making sure that it's going through these components all the way. And I'm going to say Boolean difference on the lower one, this one, and say Boolean difference on the upper one, this one. And that will ensure that the two parts can in fact lock together when you invert this. Okay, great. Okay, the final thing that we'll look at, the second final thing that we'll look at is what I was saying about, okay, well, what do we do about this? This joins to this. Now, you could just put another finger joint through that face. That would be fine. You'd have to do a little bit of remodeling, okay? But another way would be to sort of think about the logic of our wedge piece again here. So I could just go ahead and use the polyline command, assuming that I've already resolved these corners as you will. And draw that out there, draw that edge. Okay, I can then use M for move, and V for vertical. And let's just say I want to do it middle, like so. I'm going to then do and do this through CRV. Whoops, wrong one. Through CRV. So using a 3mm, I would use this piece and create more tabs that intersect with all of these spaces so that it locates well and it creates structure in this area. But the next thing that I can do is create a slot relationship between this piece and this piece. And in order to do that, I might want to move this space back sort of halfway through the depth of the joining piece here. So if I hold Shift and Control and click a surface on a poly surface, I can grab it like that. Depending on the axis that it's on, you can either use the gumball to then drag it out, or you can just use the M for move command, select a point, and then drag it out. In this case, you know, the absolute depth is not critical. I can just eyeball it. I know that something like that is going to work well for us. It might create a bit of a complexity like it has there, which you could use a Boolean function to cut off. In my case, I'm just going to bring it back away. No, I'm going to cut it off. No. Okay. One of the ways that we can more easily find the way that these two things intersect is by selecting each one and using the intersect command. And you can see that that gives us some curves. It shows us how they intersect, where they intersect. We can then use that to guide our box 3-point command. 1, 2, 3, like so. And that is going to allow me to then potentially, what I must do is split the difference on these two. Copy, cross. So, and then I'm going to say, okay, well, on this piece, I want to do a Boolean difference. That'll be this section here. And on this, I want to do a Boolean. And what that means is that we, as you can see, that those two parts now come together. They join together as a slotting function. And then adding the tabs in here is going to allow you to then really create a robust connection there that you blew up. Okay, and we repeat that on this one here, that interface, and potentially this one as well. This one's close to being, you know, perpendicular to the face, so you might be able to get away with just a normal finger joint. That one, this one is, you know, perpendicular to our world plane, so that one's working just fine. Okay, yes, this isn't a complete model. If I was going to show you every single corner, you'd get bored because you're going to have to do it yourself, and we don't have very much time. So the final step that I'm going to show you next in terms of the modeling is just about creating that edge surface. So as you remember, we have our outline surface finished. There it is, still hanging out. I'm going to just use an offset surface command. And I'm just going to re-offset that by the distance of 0.5 for our original. Now, we don't want it to be solid. We just want a surface. So, and this is going to be our, let's see, corner there. I didn't want that. I actually want it. Sorry, double check this. So we need to change our corner condition and we need to change the shaft. Better. So this is going to represent, in model space, this is going to represent our finishing component, our finishing sheet, so to speak. Now, remember, we did add our base plane, and it's got a little bit more depth to it. So I'm just going to go ahead and select these edges. Bit of funny geometry going on here, but okay, we'll do. So I might do this a different way, which is where is outline curve? There it is. We've got it. Great. We want it. And I'm just going to use that outline curve instead. Do an extrude, PRV, down, like so. Turn off the locker. Just take that. So use the join, join today. Okay, doesn't like it. No problem. Oh, oh, that's why, because I extruded it as a solid. That's fine. Okay, let's start that again. So take that curve, going to do an extrude DRV. We're going to make sure we don't have solid on for one. Just pull that down. That'll make it easier. And join those together. I'm then going to use merge all coplanar faces. And you can see that it then merges those into coplanar faces. So assuming that this pink strip that's on the outside, we're going to use, if I just drag it out as a copy, we're going to use as a guide for laser cutting our edge finishing strip out of black optics card in my case, which is 300 GSM. What I can do to turn that into a flat object is I can use the unroll surface command. It's asking if I want to explode it, which I don't. And it's asking me if I want to label it, do other things like that. I'm just going to say, no, I don't want to explode it, and I'm going to hit enter. And what you get back is this strip. So you can see that there. Awesome. That is exactly what we want. That's strip. You can imagine each of these breaks as being one of our corners. I'm then going to go ahead and hit chip base border. So pull that out. I don't need this anymore. I just want these outline curves. Now what we've got is a bunch of curves, and they're all independent shapes. I'm going to start thinking about where we lay this out as our laser cutting as well as we go. So we want one outline, or potentially two, depending on the length. Let's check the length based on the size of our material. So it's quite long. We're going to break it down into some separate parts. Okay, no problem. Where are 800? So the longest that we want is 900. So we can say that's one edge strip component. That's going to be edge strip component 2, and that's edge strip component 3. Great. We want them to be cut on the outside. So I'm going to turn on my cut layer, and I'm going to use curve boolean. And then I'm going to select everything that I need, and I'm going to select inside these groups. Just selecting the space inside. So, and then we hit enter. And what that's going to do for me is it's going to create outline here. Oh, and I got that. Okay, it's going to create that outline for us. I'm going to just turn off that. Yep, so we can see what we've got. It's going to create those outlines. Now we've lost those folds. We've lost those seams. If I bring this back in, we can see where they existed before. And I'm just going to use etch layer. I'm going to turn that on. And I'm just going to use a line command really quickly. I'm going to withdraw those. So what that'll do is it will just etch that line into the material for us so we can see where to follow. Just to make sure that we're aligned. Okay, so those components, that's our optics card edge strip. That's great. We've got all that sorted out. And we'll add that to our next second. Leave that over there for a minute. We've got our surfaces that are split. So those are ready for our 1.8. We do have one more step that we want to do, which is to add a little bit more information, maybe a north point. But finally, we've got to extract our new side components and our structure. Okay. So in order to do that, it's again a little bit tedious. We're going to use our shift base border command, and it's as simple as selecting the base we want to replicate as an outside curve. Remembering that I haven't done all of my corner geometries here because of time, but selecting those faces. So all include our base. Going to include our base piece, and we're also going to include our support faces. So those are all those curves that we want to cut out of our 3 mil. Missed something. This space. This space. And go. So those are all the things that we want to cut. We bring those out, we enter, we can see it's basically a whole bunch of individual curves. Some of them are quite easy and ready to go. These are all cuts, I should say. So we can select that geometry and just move it straight to our cut layer for our laser cutting lines. This one is already on the C-plane, so that's ready to cut as a base piece. You'll likely have a lot more detail in your base piece than what I've got. And following that, all these components, they actually need to be reoriented. Now, there's a simple way to orient things, which is the orient function and the 3-point orient function. If things are already sort of regular or planar like this, we can rotate. For example, if they're in line with our C-plane and therefore our gumball represents them on that axis, we can rotate them like that. And we can also use the project to C-plane function. We're going to delete the input, and that's just going to move everything down flat onto our plane, what we want for laser cutting there. And then we need to do that for all of this geometry. And obviously it's all sitting on different planes and whatnot. This is an opportunity that I can take to fix things as well. So sometimes if things didn't work in the modeling, we don't necessarily need to remodel that or anything. What I can do is I can just project that to the C-plane, yes. And if I don't want this little bit on the end, I can just use my curve Boolean command again, right? So curve Boolean, like that, that's inside, and that cut off that little extra piece for me. It's put it on the wrong layer because I put active. You can see that that little piece is now gone. Great. Didn't need to remodel because all we really care about at this point is our curves. And just for demonstration, I'll just do one more piece and then we'll move on to laying out a file for laser cutting. And I'm going to do a 3-point orient. So I'm going to do orient, 3-point, command name. Do 1, 2, and 3. And then I can come back in here, say, and do 1, 2, and 3. And you can see that that's pushed it into that plane. So using that as a reference in this case, but and then rotate it around and good. So we're just going to pretend for argument's sake right now that this is all that I need, even though we know that it's not, because we are running short on time. You will have a lot more components, and that's great. Final thing that we want to look at is adding some more detail potentially to this. So let's just say hypothetically, there's a road and you've extracted some information. Maybe you've traced a map. Maybe you've traced some Google Maps. Maybe you've got some information out of the near maps, which can come with data about roads, curves and things. I'm just going to pretend that there is a road that runs through here. I'm going to offset that to make it more of a road. Okay. I'm going to bring that across to it as well. And then it's just a matter of etching that in, because the part that you don't want to see is going to be hidden anyway. So you don't really need to do anything too extravagant. And you don't really need to split this out either, based on the different steps and how they overlap. You can just etch it twice and some of it will get covered, but it'll be, the information is then replaced by the next step anyway. So you can do the same thing with something like a scale bar. You could use text command gone, that's hanging out on the monitor. We could use some text. If you can find it, I'd recommend using this font called Mexsoft _font -1. Sometimes that just exists in Rhino. I'm not entirely sure if it's a particular Rhino. But, you know, our site might be called, I know that for a fact that this site is in Tonga. I can't remember specifics, but I'm going to call it Tonga. And I'm going to say it's 1 to 500, but whatever information that you want to include, looking a little bit small, bigger, make it a bit bigger here. Okay, so whatever kind of information or drawings you need to include, so that could be scale bars, that could be north points, things like that. You just want to make sure that if it's on one set, that it is also on the other set in the same position, okay? And that will etch in that information onto the surface of your model. Okay, so the final step with this information that we've got, just to make my life easier, I'm going to make sure everything is grouped, especially on these sets. And I'm going to make sure that these sets here are grouped. Oops, group that. So Control G or type group. These ones I'll leave free. So we've got three sets. We've got our optics card, which is our thin edge that is, in my case, a black thin card. We've got our top surface contour pieces, which will be laser cut and then stacked, which is 1.8mm box board. And then we've got our structural component, which for my design is 3mm box board. So three different materials that we're going to lay out in our laser file. I'm going to go back to our Fab Lab knowledge base, and under submission template files, I can find Fab Lab laser cutting template R5. Okay, I'm going to launch that in, oops, I'll launch that in the new Rhino for me. Now that's an R5, so it'll launch in Rhino 6, Rhino 7, Rhino 8, Rhino 5. We do that on purpose so everyone can use it. Take a second because of course. There we go. Okay, so now you can see this is our default template. Each sort of stack that we have here for us is a different material. So we've got three materials. I'm just going to copy this down. So how we choose to do it. My materials are all 600 by 900. 600 by 900 sheets represented. I don't need this one. Don't need this one. And don't need this one. If this material on top, we're going to start with our, say, we're going to start with our 3mm box board. So our material is box board, choose, and the thickness of it is 3mm. Okay. I can then go back over to here and I can say, okay, these are my 3mm box board parts. I'm going to select them. Just Control C in Rhino will copy to clipboard. And then reopen my template. And I'm going to hit paste or type paste into the command line, and you can see my geometry comes in. Okay, so we can then start using, in my case, the gumball, again, on and off down here. You can just drag it around on the C-plane if you're in the top view. It's very simple. You can see that the parts aren't quite fitting. Yes, I could make these all fit onto this sheet. Just for demonstration's sake, I'm going to show you, if you need multiple sheets, I'm just going to copy out, oops, holding Control, dragging on my gumball, or just using the copy command. Same material, the same thickness. I'm just going to copy out another layout for it and move my parts onto that. Okay. Now, it's a good idea to nest your parts up nice and tightly. There are instructions on the knowledge base about how tightly that can be. And in fact, things like this where we're cutting through, they can share edges. So we can share an edge like so. We just can't have duplicates like this. So you'd have to get rid of one of those edges. But ultimately, the cutting would still do its job if those edges were shared. It's a good way to keep things quite efficient if you've got lots of parts. Okay, the other thing that I would change is I've changed my job number. So you would have submitted to the queue by now in the Fab Lab, and you would have got a job number by email. So that happens before. You need to do that before you save and upload your file. That job number is really important for naming your file. So I'm just going to pretend my job number is 10,099. Input that there, and I've got X number of sheets. So in this case, I'm going to have 4 sheets in total. In fact, that's incorrect because I think on the next 1.8mm, we're going to need 2 sheets. So I'm going to have 5 sheets in total. So then I would just change this to 1 of 5 and do the same for the next sheet. It'd be 2 of 5, etc., and on through the whole set. And that just helps you and us keep track of your work when you've submitted it and ensure that we don't miss out on the sheet. We can check as we go. So if we were moving on to our 1.8mm box board, I'd be 1.8mm, and then process of, so this is our 1.8mm geometry. Control C, paste in my command line, drop that here. And these are quite big pieces, that's fine. So drag in and just that section. And finally, we're going to do this edge strip. The so, and then I probably use and I would adjust this to reflect that material choice, which is optic card 300 GSM. The other thing to note is these tags here, so you can delete these if you don't want them. So use our material, which is default, and tape objects. What that means is we'll use masking tape to hold all your parts in place after the cutting. If you don't want that, you just need to delete this instruction. So grab it and hit delete on the keyboard, and we will try and bag it or make some other method up. Ideally, we are taping actually. So, okay, the final thing that we need to be aware of is where our geometry exists and how it's being represented. So the way the laser cutting system works is when we print, quote unquote, we're actually looking for specific colors to align with specific processes. So red is always etched, black is always cut, and the settings on the machine align to those colors. So it's really important that our geometry is on the correct layer and that it's set up correctly. When I dropped my geometry in, it brought its layer information with it from our other Rhino file. I'm going to select objects from my cut layer, see that there, and I'm just going to move them to the Fab Lab folder and the sub layer, which is cut. So I know that they're in the right place. I then go into my our properties, object properties here. You can see we've got 36 curves. They are on the cut layer, and their color, their display color, is by layer. That's correct. We don't want any other option. We don't want by material or by parent. It must be by layer. If it's not black, it won't cut on the cut layer. Same for our edge. We can select those objects. I'm going to move those to our edge layer. So, and if they're on the right layer, if they're red and they're on display color by layer, they will be correctly etched. That is the long and short of it. The next thing that I would do is I would go and save my file. So say save as, and we're saving as a Rhino 7 file, right? And we're going to use a naming convention. If you want to check the naming conventions, back on the knowledge base, we've got naming conventions for a 3DM. 3DM is a Rhino file. So we've got our job number, we've got the technology, which is laser, and we've got the version. So our job number, my made-up job number, which I've already forgotten, I think it was 10,099. So 10,099 underscore laser underscore B1. So that tells us that's your job number. This is the technology that it belongs to. This is the version. It's important to know the version because it's quite common for people to want to adjust their file or make a mistake. And when they resubmit that file, we need to know that we've got the latest version. We've got the newest. Go ahead and save that file wherever it makes sense to you. You would have got a link when you submitted your job to the Bureau, and you can go ahead and upload your Rhino file to that link for processing. If we go back, I can go years. Back. We go back to our website, we can drop into our submit a job via the app function, submit our job, laser, fill out the information here. You'll then get that email. You'll be able to name your file with that email, with the job number that comes in that email, and you'll get a link to upload your file. Once your file is processed, you get an automatic email saying it's completed and where you pick it up from. And as well as that, you'll get a link for payment. I think that for today is everything. Did you have any questions, Brianna, about any of that? I might have a lot. Okay. Well, hopefully I haven't been on mute the whole time. From my end, it looks like the microphone's working. And there's going to be another one of these sessions. I believe it's the 24th of September. In the meantime, if you do have any questions, you can, again, jump back to the Fab Lab website and you can book a consultation. And you can book 15 minutes with one of our technicians. If you're struggling to set up your file, there's a particular thing that's holding you back, do that. Come with a file, ideally come with either a file on a USB or bring your own computer if you like to as well, so that we've got something to work with. And we're more than happy to try and get you over those hurdles. We know this stuff, inside and out. So whatever you need to do. On the next session as well, as I said, I'm going to go through not just complex edge conditions like we were trying to deal with this one. I'm going to go through things like intervening in the surface and how we make cutouts in the surface through the contour model process. It's not the most malleable for that, but it can certainly be done to some extent. Okay, well, thanks, Brianna, for coming. And for those watching the recording, I hope this has been helpful. We do appreciate your feedback. I'll send out an email. Like I said, this is the first time I've run it this way. We might have had some technical difficulties in there. And hopefully I can iron those out in the next version. Okay. Well, good luck and have a great night.